Hello everyone, my name is Ashutosh Kulkarni and I am a research scholar in the Computer Vision and Pattern Recognition Lab at the Indian Institute of Technology Ropar, and I am here to present our work entitled C2AIR Consolidated Compact Aerial Image Haze Removal. Aerial images are widely used in applications such as drone surveillance, building extraction, and object detection. The cleaner data ensures better accuracy in functioning of these algorithms. However, the visibility of aerial images is significantly compromised by the presence of hazy degradations, resulting in loss of crucial details. To address this issue and restore important information, an aerial image haze removal algorithm is employed. This algorithm effectively removes haze degradations, thereby improves the visibility and enhances the interpretability of the images. Existing approaches often utilize different models for haze removal at various densities, which may not be a practical solution. Moreover, their models are computationally intensive, posing limitations in real-time scenarios. In contrast, the proposed method uses a lightweight consolidated model for aerial image haze removal. We propose a consolidated compact transformer-based network for aerial image haze removal. It has two subpaths. The upper path processes the images on their original scale, and the lower path has access to multi-scale features as well as coarse outputs of the previous path. The main contributing elements of the proposed network are density-aware query modulated block, cross-collaborative feed-forward network, and adaptive gated feature fusion. In the density-aware query modulated block, we correspond the queries as density extracted information, where the output features can be obtained with relevance to the extracted density features. Aerial images contain a diverse range of structures, including buildings, roads, vegetation, and water bodies, each with distinct shapes and sizes. One of the challenges in image restoration tasks is to learn such intricate and varying structures. As a solution, the proposed cross-collaborative feed-forward network incorporates cross-kernel collaborative learning that enables the ability to effectively attend to diverse receptive fields within the input features, leading to enhanced perceptual quality in the resultant images. The proposed adaptive gated feature fusion block provides scale-level feature attention and intra-feature attention to provide relevant importance to features from either original or multi-scale transformer stream. We utilize mix-up strategy for weighing the features. We make the weighing parameter trainable using a trainable tensor. This parameter is then multiplied with respective stream features for deciding their importance. Following this, we provide gated attention to the weighted features to provide intra-feature importance to relevant regions in the features. Now we will look at the results analysis. These are the qualitative results on the SET1K dataset. These are the qualitative results on the RISE dataset. And these are the qualitative results on real-world degraded aerial images. As seen from the results, the proposed method is able to restore the degraded image with more naturalness than the existing methods. These are the quantitative results on SET1K dataset having different densities of haze. These are the quantitative results on RISE dataset for aerial image dehazing. These are the qualitative results using different settings of training. Here we have analyzed the method without using the proposed blocks. As we can see, the proposed method is able to give better results than the other settings. These are the quantitative results using different available settings. The proposed setting is constantly outperforming the existing methods. In order to verify the generalizability of the proposed method, we perform experiments using UIB dataset for underwater image enhancement. As we can see, the proposed method can be applied for such other domain restoration tasks as well. So in conclusion, a compact consolidated transformer network is proposed for aerial image haze removal. Quantitative and qualitative analysis are provided on synthetic and real-world images. Ablation study is provided for each proposed module. We examined the generalizability of the proposed method on other image restoration tasks such as underwater image enhancement. So thank you so much, and please visit our project page for more details.